Hey everyone, let's take a look at some interesting and unique functions and see if we can look at what limits are going on here. And so for our first function, we're going to look at the unit step function or Heaviside function. So Heaviside it's named after the guy who discovered this or came up with this function. And the function itself, oops, I spy a little typo in here. I'm going to fix this for your guys' notes. That X right there, that should be a T. Okay. Um, so this is U of T equals 0 if T is less than 0. And then U of T equals 1 if T is greater than or equal to 0. Okay, so this is a piecewise function. Two pieces, and a different piece is active depending on which t value you're looking at. Okay, so when we graph this, t versus u of t, okay, as long as t is less than 0, then u of t is 0. All right, so that looks like this. Okay, 0, 0, 0 values along there. Okay, and at t equals 0 itself, the function value switches to 1. So we'll say this is 1 right here. When t equals 0, u equals 1. So our point goes right there. Now, leading all the way up to t equals 0, okay, the values are 0 along here. So we would put a hole to show that this piece of the piecewise function here, this has switched off, and that we are now switching up to here with a value of 1. And then when t is equal to 0 or greater than 0, the value is 1. Okay, and it just keeps going like that. All right, so that is what the unit step function looks like. And this you might see in some different applications. I've seen this used in engineering and physics. And what this is used for is a sudden occurrence of something. So for instance, this can be used when you're switching on some sort of electrical circuit. All right, or a current, electrical current of some sort. As time is progressing, there's nothing happening. And then you flip the switch and then a current is flowing. So nothing and then something. Or another application might be the application of a force very suddenly. Now, in most practical real world circumstances, force gets applied a little bit more gradually, I believe, but we could say there's no force being applied to your object, and then all of a sudden, wham, it gets hit with force, and then that force is applied for the rest of whatever time period you're looking at. So the overall idea of this function is that something has suddenly happened at this point in time that was not happening before. Okay, you go from nothing to something. Okay, so what we want to look at here is the limit as t approaches 0 of u of t. Okay, so the limit of this unit step function as t approaches 0. And remember from our definition and from what we were looking at before, that when we're making that approach, we're using t in this problem, we were using x in the definition, but we're going to let t, in our case, get close to 0 from both sides. Okay, x gets close to c from both sides. for us, t is going to get close to 0 from both sides. Okay, so let's see what happens with that. All right, so here's the point that we care about. Well, maybe not necessarily. Here's the point in time that we care about, t equals 0. Okay. So remember from those other graph problems, we want to bring in our values horizontally, approaching 0 in this case. Okay. So put a finger on the function on each side of 0. So put a finger here, and then really make sure you're putting a finger on the function itself. So on the other side, you'd put your finger here. Okay. And then we're going to move those fingers toward each other. We are going to approach t equals 0 from both sides. So we're approaching in, we're approaching in. Ideally, you would be doing this simultaneously, but I can only write with my little pen here in one place at a time. Okay, and we get very, very close to t equals 0, and we see that there's still a big gap between our fingers. Okay, now that's different. That hasn't happened before on any of our other graphs. Okay, remember these three guys? We brought our fingers together and they came to this value L. They still approach this value L. Let's see. Here with the little quick graphs, we could see very clearly it was approaching the same value, same y value from both sides. Okay, on our unit step function here, we are not approaching the same value from both sides. One of our fingers is going in towards y equals 1, and then our other finger is coming in towards y equals 0. So that's an issue. All right. In fact, it's so big of an issue for this limit that we have to say the limit as t approaches 0 of u of t straight up does not exist. Okay, it does not exist, and that is our final answer for the limit. It is possible for a limit to not exist, and this is one case of that. So this limit does not exist because our function u of t doesn't approach a single value. Right. Single value as t approaches 0. Okay, it actually approaches 2 different values. We could make that little note here as well. 2 different values. If the y values don't match up from both sides, your limit does not exist. Okay, so there's our very first limit that does not exist. And we'll look at another interesting function in the next video.